What is going on, everybody? Welcome back to the blackboard. We're going to continue on with non-homogeneous ODEs. This time we're going to solve the initial value problem. And these questions, we are given the ODE, we're given the conditions, and we're also given the complementary solution or the homogeneous solution set. And again, if you want to learn how to solve the homogeneous portion of this problem, I do have links where I solve homogeneous systems for constant coefficients, so definitely check that out. But other than that, let's continue with this problem. So our first part, we're given y double prime plus 4y is equal to 2t, and then our solution is with sines and cosines. So we can do rule number 1 and just have a equal to not a, have our solution yp equaling to a of t. And so we don't have to take the second derivative because that'll just be equal to 0. So when we plug it in, we'll get 0 plus 4at is equal to 2t, or a is equaling to 1/2. So our general solution will be equal to c1 cosine of 2t plus c2 sine of 2t plus 1/2 times, or t over 2 pretty much. So now we can plug in our solutions, or our conditions. So at y is equal to 0, we will get that this is equal to 0, this would be 0, so this would just be c1, and that is equal to, that's supposed to be a 1. I really did not. I didn't actually see the other one. But okay, c1 is equal to 1. Cool. So now it's derivative. Well, no, it's actually not that bad because we don't have to do product rule. So its derivative will just be negative 2 sine of 2t, or plugging in 1 here, plus 2 cosine, I guess 2c2 cosine of 2t plus 1/2. And so when we plug in y prime of 0, yep, 0, you'll get that that's equal to 0. 2c2 plus 1/2 is equal to 2. Do a little bit of math, algebra. We see that c2 is equal to 3/4, making our solution, general solution, or actually our I guess it's not particular solution anymore, but making our solution being cosine of 2t plus 3/4 sine of 2t plus t over 2. Now for part B. Part B, we have our function equaling to e to the t, and we can see that in the homogeneous set we don't have no e to the t. Lucky for us, we can let our particular solution equal to a e to the t, which is the same as its derivatives. So when we plug in, we'll get a e to the t plus 3a e to the t plus 2a e to the t, and that is equal to e to the t. Exponentials cancel out, and we are left with 6a is equal to 1, or a is equal to 1/6. So this puts our general solution to be c1 e to negative 2t plus c2 e to negative t plus 1/6 e to the t. And so when we take its derivatives, it will be negative 2 c1 e to negative 2t minus e to the t plus 1/6 e to the t. So when y is equal to 0, we'll get c1 plus c2 plus 1/6, that is equal to 0, and then y prime of 0, that would just be negative 2 minus 1 plus 1/6, that is also equal to, no, it's not also equal to 0, that's equal to 3. Forgot to add this constant, c1 plus c2 plus 1/6 is equal to 3. So now we have two equations with two unknowns, and so here's what we can do. move this to one side, and then I'm going to rewrite the bottom part. So negative 2c1 plus c2. Is it plus c2? It's negative. It's minus. Minus c2 is equal to 18, 17 over 16. 17 over 6. And so what we can do is we can add these two equations. So we can cancel out the c2. And so this leaves us with negative c1 is equaling to 16 over 6. So c1 is negative 16 over 6. I should just leave it like that. c1 is equal to negative 16 over 6. So our c2 will just be equaling to, well, negative 16 over 6 plus c2 is equal to negative 6. That'll be 15 over 6. And so our solution will just be equaling to negative 16 over 6 sine or cosine? Oh, no, neither. E to the negative 2t plus 15 over 6 e to the negative t plus 1 over 6 e to the t. Yeah, let's stop it right here and then do the other two examples in another video. So I will see you guys for part 2.